Well, welcome to the January 30th, 2024 session of uh, Tangerine, Clementine, SDR, and Hamside technical session. So my name is Dave, KV0S, and this week I've been mostly working on, been having to do a lot of repairs. I had a water break in the house, so that took I've been managing contractors, but I also was able to work with Rob Robinette and Michael Howen on getting some stuff set up on my K9Q radio and Whisper Demon. So that's most of my work. Next on the list, we have Nathaniel, W2NAF. Go ahead.
Thanks, Dave. Classes started at the University of Scranton this week, and I've been trying to make good use of our new ham radio station. I have a communication systems class I'm teaching, so I've been using that in that class, and I've also had our open air hours on Thursday nights. Jonathan Rizzo came over last Thursday night to the new station. We had a couple students there as well, and we had QSOs with Bill Engelkey and W8EDU at Case Western and Steve Serwin, WA5FRF. So it's really been working wonderfully. And then aside from that, I've just been, really trying to keep up with the different administrative tasks at school and the teaching and just keep things moving along. Still trying to work on this GRL manuscript, have a few more details to finish up. W2NF, back to net.
Okay. Next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Oh, yeah. Hi. I've been still doing some stuff for the Grape 2 people and miscellaneous and other here in with my stuff. Otherwise, nothing very exciting to report that I can remember. But back to y'all.
Okay. Next on the list is Michael, AAAK. Go ahead, Michael.
Well, thanks, and greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is Bill Engelkey, AB4EJ. Go ahead.
Uh, Thanks, Dave. Been working on a few things with Franco on we're going to upgrade the security of the personal space weather station network server. We found a couple of security shortcomings, and Franco was going to help me get those sorted out. We are also working on a number of other things to upgrade the website, particularly to include it's going to have its own version of SuperMag, which will allow you to bring up, observe, and compare magnetometer readings, and hopefully we'll figure out a way to also include the plots of the grape stations, as well as we're working on to be able to plot multiple sub-channels, because the RX888s will be providing multiple sub-channels. So we're coming up with an enhanced plotter software which will be able to handle any number of channels that are included and as automatically in that. So okay, that's the story from here.
Very good. I look forward to those changes. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. There's my picture coming up now. Not that you need it. Not a whole lot going on here. Working on a couple of presentations for one for our club here and one for the club in the adjacent county. The adjacent county, that's one that I've already written, but I can never give the same presentation twice. I have to go back and tweak on it a good bit. I think I've got most of the tweaking done on that one. Still got work to do on the one for this county, which Nathaniel was good enough to give me some good information for. but that one's not due until May, so I've got a little bit of time on that one. But not a whole lot spectacular except meeting a few nets on the air. Back to net K4BSE.
Very good. And next on the list is Bob, N5BRG. Go ahead, Bob.
Hello, everybody. I just wanted to check in. I've been keeping my head down and working on projects here and making some progress. And wanted to catch up on what's happening here. So back to you, Dave.
Yes. And well, I'll go on down the list. Next on the list, we have David, N1HAC. Go ahead, David.
Good evening, everyone. We're continuing to work on our AM Doppler system, getting that to be redeployed and ready for the eclipse. And this Saturday, I hope to be giving a presentation to our local radio club, Twin State Radio Club, on the festivals of eclipse science. So, and we just got 4 inches of snow, which is a big snowstorm for this year. Back to net.
Well, enjoy. Maybe you can go skiing. Next on the list is, let's see, Franco, K4VZ. Go ahead, Franco.
Hey Dave, everyone, I've been working on a couple of things with Rob to get all the data ready for the personal space weather stations with Bill to get them secured and get them there. At the same time, I also started I've been working with Phil Harman, VK6PH, on his idea of a transceiver based on the DFC approach, which is similar to what Phil does for Kenanky Radio. Has been, I've posted something on the next Gen SDR group, and it seems to be a very good feedback on that. So hopefully it'll become something, future and well received. And I also been working on a side because I'm also supporting the so-called SDR Play Radio with upgrading all the software because they released a new version of their API in a new model. And then I had Winterfield Day on Saturday where I did some JS8 core. That's all. Back to you, Dave.
Well, you're pretty busy. Anyway, thank you. Next on the list is Jay, WB8 SBI. Go ahead, Jay. Is Jay there? There he is.
I'm here. The Zoom put up a couple of little gotchas there that I had to work through. Not really a whole lot to report here to the group tonight, so I'll just say 7-3 to all, and everybody stay warm, stay safe. Back to net.
Okay. Next on the list, we have Jim Ellison, K5NRA. Go ahead, Jay. Jim, sorry.
I don't have much to report here. This is my first time check-in, and the invite looked interesting, so I'm anxious to hear what everybody has to say, and I'll be back to the net.
Okay, very good. Next on the list is Jonathan, KC0EEY. Go ahead, Jonathan.
Hi, everybody. I've had a moderately busy week. A lot of VLF related stuff going on. I shipped out some engineering units, the Trimble resolution SMT and SMTX. Those are GPS timing receivers from Trimble. Now Pro Tempus. I was able to get updated firmware, and I shipped those out to the maintainer of GPS, Damon, for him to refine his support for their protocol. So it feels good to help out a software developer by providing them engineering samples. Normally people don't do this, but he's more than willing to more than willing to accept them and improve GPS daemon, which is a really good thing because it's just a wonderful piece of software. The other big thing is the server for Abilene.org, that is the website for the author of VLF RX tools, has been upgraded. And what that means for me is that the VLF Spectrum stream that I was sending to his server, it was a web host in Germany, but he recently got symmetric fiber internet at home, and he's actually able to host his website and streaming server from his internet connection. And so what I had to do is I had to log into the VLF system and update the server address that it's streaming to. One of the benefits to this data upload is that not only you can actually listen to the VLF stream, but you can also look at different sorts of live events or archived events, Whistler events, and Dawn Chorus, for example. The last one down here, Springbrook Township, that is the VLF receiver. These are the VLF receivers that he hosts, or that also upload to him different locations around the world. And if you click on events, it will bring you to this page showing the last recorded events. This was a Dawn Chorus event. These are reassigned spectrograms of a Dawn Chorus event. You could see a Whistler here in the corner, October 24th. And then also, not only are, so this was the VLF spectrum that I was uplinking to him. It was Vorbis compressed. So the bandwidth footprint is actually really light. So this is what you could accomplish, even using Vorbis compressed audio. You could do real analysis like this. And this is a information screen. You could see the VLF power spectrum. You can see it's actually actually quite noisy. The around 2 kilohertz. That's the that is one of the Earth ionosphere waveguide modes, and you could see that there's quite a bit of noise. Normally this will dip down, but there's actually quite a bit of noise. This is local interference. He also has an amplitude histogram for each of the bits. He down mixes it to 16-bit. And also this is the alpha F1 frequency spectrum. So the Russian alpha navigation system is it still broadcasts, and usually around January, December, the signal comes in actually quite clearly, but it's hard to actually listen to due to the fact that there's so much noise. I haven't really been able to figure out what what the source was. So this is Paul's website. I advise everybody to check it out if you'd like. I could post a link to it. And this is kind of what I have in mind once I get my network of VLF receivers. That is all I have. Back to the net.
Well, very good, Jonathan. Next on the list is Dylan. KN6 IVW. Go ahead, Dylan. I don't know if Dylan, there he is. Dylan, are you there?
Can you hear me?
Now I can. Go ahead. Well, we heard him.
Good. Sounds like he's having trouble.
Yep. He usually often is coming in on his cell phone. So we'll go ahead. Next on the list is Michael Howen, AC0G. Go ahead, Michael. I don't hear.
That worked.
There.
It was popping up a notice that the meeting is being recorded, and I couldn't unmute until I agreed to submit myself to that, I guess. Hello, everybody. I'll just, I've been pretty busy with my daytime job this week, but have been working a little bit on helping with Franco, who's doing the real heavy lifting, and Rob on getting the IQ streams for WWV organized in a way we can easily upload them to Bill's server. I've still been whacking away at the discrimination of WWVH from WWV, and was stimulated by Phil's comments about the potential utility of WWV Sim that he wrote to enable that. So I've been looking into some of the autocorrelation possibilities that might enable me to do that. So I'm playing with it both in Python, but also doing some visual simulations since GNU Radio has all the tools for that, using GNU Radio. That's it. Back to Ned, everybody.
Oh, okay. Well, and let's see. Next on the list is Phil, K9Q. Go ahead.
Hi, everybody. Not much to report since last week. I'm getting ready for some travel. I'm speaking on a panel session at the NTIA is holding in DC on Thursday. Basically, my job there is to try to promote ham radio and its utility for bringing people into STEM and, other useful things. So any last minute brilliant ideas for, 2-second elevator pitches to give for ham side to show the worth of hams having spectrum, let me know. I mean, I already have a pretty good idea what I'm going to say, but sure
I can tell you one of my communication systems students today said, I hadn't really heard of ham radio before, but now that we're actually looking at it, it's kind of cool. So
all right. That's a good one. That's a good one.
Yeah.
I mean, one line we had a prep meeting today with a bunch of people on the panel. And I used an analogy that Franklin Antonio started using years ago that I always thought was excellent, which is that you can think of the spectrum, ham spectrum, as something like a national park. It has value that is not direct commercial value, but it is still very valuable to society. And it is often under threat.
And I was also telling my students, I think one of the things that's really unique about ham radio is that you really get to experience the communications like under the hood in a way, because with cell phones, with computers, we're using communications all of the time, but a lot of the noise, the errors, they're all hidden from you with the error correction algorithms and things like that. But with ham radio, you can actually see the spectrograms, you can experience the errors, you can hear the noise, you can hear what works, you can hear what doesn't, you can twiddle the knobs. It's a totally different experience, much better for learning.
Right. The question I have mainly for you guys is, I'm an engineer. I'm going to come into this, and I already have plenty of examples of, I think, ham radio's utility because we created some technology. I'm going to give myself an example. Fooling around with internet over Packet radio in the early 80s, long before anybody thought there was a commercial use for this. And we didn't think there was either. I mean, we did it because it was fun, and that put us out there years ahead of the industry discovering this. I mean, I went to Qualcomm in 1991 mainly to continue that work commercially, and it still took years for me to convince even people like Franklin internally that that people actually found it would find a use for internet over radio. I mean, it's hard to believe now, but it was absolutely true. So, but my question to you guys is, okay, what is the corresponding role for ham radio in science? I mean, this is the group. If any group is doing science on ham radio, it's you guys.
Mm-hmm.
Now, I don't want to oversell it,
Yeah.
and promise more than we could possibly do, but I also don't want to undersell it.
Well, I think we have a few particularly big selling points. One is the geographic diversity and spread. If you're trying to remotely sense something as large as the ionosphere in space, you just need so many data points, and you need to
Mhm.
look at the environment in so many different ways. And we have wonderful professional instrumentation. The things like the GPS network is fantastic. We have a nice network of ionosons. We have nice networks of super darn radars and coherent scatter radars, but it still doesn't cover everything. It not by any stretch. And so ham radio gives a certain additional geographic coverage.
Okay,
Another inter
I'm definitely going to try to push
yeah.
ham side just to make sure I
Yeah.
grab it correctly.
Another interesting thing is, where else do you have publicly available actual HF communications observations? Um so like we know that the military uses HF communications. We know that aircraft uses HF communications, but there's no publicly accessible or unclassified record of all of those links for people to study. And
Mhm.
yet those agencies need to know how these things work. So the amateur data provides a very interesting the RBN WhisperNet PSK reported that they now go back a whole solar cycle. So you now have a quasi global, fully publicly available database of these communications that just is totally unique. So I
Okay.
think that's
All
also
right.
valuable.
All right. I mean, I have a few more questions for. I don't want to take over the meeting. Dave, are we through the list?
No, we got a couple more. And
Okay, I'd like to come back to this.
And
Rob,
Phil,
Rob
do
is,
you, okay.
let me say, Rob is planning to do a presentation on what he's doing with WWV K9Q. Are you?
I don't know. I'd call it a presentation. I just wanted to have a discussion about it
Okay.
and make sure we're on everybody's on the same page and understands what we're doing. And
Okay. So we're going to have that too. So
Okay. Yeah, I mean, I just want to ask a few quick questions on, I mean, the general utility of ham radio for science, not just ham sci, but in general. So I'd like to come back to that because I mean, I'm doing this in a couple days. So
Hey, Phil,
what?
yeah.
Even though your concentration is in science, do you want to touch on the emergency communications aspect?
Not so much at this particular meeting. It's about spectrum planning and the future of STEM education, all that kind of stuff, which is one of my buttons. So I mean, that's why I was invited to this thing.
Phil, did you read the Frontiers article we wrote and published last fall?
I don't think so. Send me a link, please.
I'll put it. So this came out of the National Academy of Sciences had a decadal survey of space physics, and I led and we submitted 2 white papers to that National Academy's survey. And then following
okay.
on that, the Frontiers Journal, they had a special issue where they asked people to tighten up their articles and submit them for peer review. So the link I just put in the chat is the result of expanding those 2 white papers, and you can see that we've got a large number of co-authors on there that helped contribute to
Yeah,
this.
I got it. I mean, is there ever a scientific paper that doesn't have at least 10 co-authors?
Right.
Well,
yeah, but
more
I think
so
that will
in atmospheric science or
I think that will
Okay.
speak to a lot of what you're trying to
Great. Okay.
discuss.
Yeah, I didn't want to monopolize the meeting. Just Dave, you go ahead and go through
Oh,
everybody.
okay. So we got a couple more. Let's see. We have Randy. Poor Randy. I don't think you've been here before, but you got stepped on by everybody starting to talk. Go ahead.
Actually, I'm rather grateful I got stepped on because I'm the youth outreach officer for my amateur radio club, and I'm a guest of Ed Afchek, actually,
Okay.
who's your public information officer, and told me about this meeting. He's in Florida right now, where our amateur radio club is located, and we're trying to do an outreach into the public schools. I'm actually a retired educator.
Oh.
And so I'm actually fascinated by Phil and what he's trying to accomplish.
Yes.
And I would like you to carry on, actually. So I'll shut up and
okay.
take it back to you, Net.
Okay. Well, the one unique thing about this group is they're amateurs, but many of us are either academics, have been academics, or engineers. And so we're trying to mix a different aspect to amateur radio. And that's the interesting component of this group. I do want to give Tom McDermott, N5EG, a chance to talk, and then I'm going to turn it over to Rob and then I'm sure Phil will jump in with Rob's stuff.
Okay, thanks, Dave. Good evening to the group. Phil, the FT8 Live code worked great, installed no problem, and got 4 and 8 FT4 and FT8 decoding working. I put out a third video on getting started with KA9Q, focusing on decoders, and it's picked up about 20 or 30 views so far. So if anyone's interested, I was amazed firing up FT8 for the first time, and inside of 2 minutes, I probably had 50 or 60 spots. I was just astounded how fast they come in on FT8. So quite a few on FT4. And that's about it for the week. Back to the group.
And I want to commend Tom for this set of videos he's making. He's doing a very nice job explaining K9Q radio for people that are trying to work their way through the different pieces. So thanks, good job, Tom.
Thank you.
And so now we'll get to Rob Robinette, and he's been working on collecting WWV data, and there's a number of us that have been involved in this. So I'll let Tom tell you all about that. But using HFK9Q radio to essentially collect a mega sample of the grape style data, if that's more or less correct. Go ahead, Rob.
Well, yeah. So what we're doing is using the adding to the Whisper Demon software service, adding the capability of also recording all of the time stations, WWEB and through 25 and the 3 CHUs, recording all of them simultaneously. And then every day creating a 10 hertz wave file, 10 hertz bandwidth wave file, which we'll upload to the to Bill's server. So there are already, I have 15 Whisper Demon RX888 stations that are busily recording these, all of these wave files. Of course, on many stations, there's nothing on WWVB. The antennas don't deliver it, but it's so inexpensive CPU wise and memory wise to add all of the stations, and then you don't have to worry about who's configured which way. So they'll upload them. I mean, the only cost is Bill's going to have all of these. He's going to have 10 bands or 9 bands of 10 hertz wave files every day from all these stations. So that's okay with you, Bill? Is that you think that's okay? Good. Okay. I think you've established that the method of recording and decimating the files are recorded at 16 kilosamples as per Phil's suggestion. So there's 16 kilosamples, and then at the end of the day, and they're cached locally. And at the end of the day, immediately after, as we roll over to the new day, those the 16 kilosample files, which in aggregate are about 56 gigabytes of uncompressed wave files, are compressed down to 10 hertz bandwidth, and with a single file, which is about 3.6 megabytes in size. So only the 3.6 megabyte file is uploaded to Bill's server, but the 56 gigabytes, well, are stored compressed, FLAC compressed, are retained in the individual Whisper Daemon sites. So, and I'm putting in the special casing the days around, the eclipse, plus and minus 1 day. So those 3 days of 26 gigabytes each day is the compressed size of the wave files. So there'll be about 75 gigabytes of recordings at all of these sites that could be uploaded if there were interest, if there were some information that one wanted to extract from them. So I think that's a reasonable amount of storage to reserve on individual sites. Most people at least have, uh, 500 gigabyte storage systems. So this represents about 20% of their storage. And eventually we can flush them out, but I thought we'd leave them there for a few months in case there's a reason to gather them. So that's the basic system. We had been working on a system where the Whisper Daemon clients would upload those 10 hertz wave files to a Whisper Daemon server, and then from there they would be uploaded to Bill's server. But Michael, I think, reminded me that there's really no reason for us to go through the Whisper Daemon server, and we're going to have the individual Whisper Daemon clients uploading directly once a day to Bill's server. So I don't think there's anything for anyone to do. Thanks to Franco. Franco just sent me another Python file that I will be implementing or incorporating. But all of the configuration goes on basically is done through Whisper Daemon. The only thing the user really needs to do is define a schedule that includes those one or more WWV files channels, and enable the updating of their grape data up to Bill's server. That process involves a password, which is known as a token, I think, in the grape world. I think that can be now done in a way in which that token stays secure and owned only by the individual Whisper Daemon users. So I don't think there will be any additional vulnerability, or any of those tokens I don't think will be floating around in any vulnerable place. So anyway, that's been my activity. I think Bill has confirmed, and I think Nathaniel as well, that these WAV files are in a useful format that's comparable to what you get from the grape stations. And of course, they have the advantage of full bandwidth recordings being archived as well. We have also, by the way, so that's the software features that I'm incorporating into Whisper Daemon and deploying with Michael's help and Franco's help. So that I keep saying it'll be the next day, but we learn how we want to do it, and everything changes. So now maybe tomorrow they'll all be doing it.
Yeah.
But it's a matter of days to get this. Both you have to I have to install it. I have to test it. I use one receiver at KFS to test this, and then once I test it, I try to install it and configure it at some other sites that I also have control over, easy access to. So that process is near to completion. As a way to calibrate this Whisper Demon Grape feature, Dave Schwartz, who is with us, I think, no, not Dave Schwartz is, and I see Jay Schwartz. Dave Schwartz, who is, I learned, the president of the WWV Amateur Radio Club. I didn't realize that, but a HAMSI member. Dave has deployed a receiver site that is about 2.5 miles, I think, 4 kilometers east of the WWV transmitters. So that his site, W0 DAS, is reporting both. Of course, I assume it's reporting to Grape. That's an independent of me, but it's also recording, and will soon be reporting the Grape recorded WWV Grape transmissions. So it's a way for us at once that's in operation, and hopefully there's a way for someone to compare the Grape recordings from that site with the Whisper Demon Grape recordings that will come from the same antenna at the same location. And so that would be one way, I think the best way to verify that this system that I'm deploying is delivering data that's comparable to what's coming from the Grape 1 and Grape 2, well, mostly, I guess, from the Grape 2.
We'll be able to do that as soon as we get our multi-sub-channel plotter working.
Okay. Well, anyway, the data should be there later in the week. The stations are recording the wave files. So actually, once I get this feature debugged and installed and deployed at the sites, then there'll be in many sites. It depends on how much storage space they have, but some sites have over a week of wave files there. So there'll be a week's worth of your 7 of the smaller 10 hertz files will come up to you from some sites. Other sites have only 3 or 4 days of storage space. So, but the recordings are happening already. The feature is incorporated and enabled at all these 14 sites. So anyway, that's my current focus, and I want to get that out. So that's my receive side focus. On the transmit side, we've been working to verify the receivers, the 888 receive systems, the accuracy of the frequency reports, and we're a little bit uncertain. I think we're not. I think we have greater confidence in radio D K9Q's frequency. And when I say accuracy, we're talking about it needs to be accurate to better than 1/10 of a hertz. So one of our areas of study and concern is that the Kiwis seem to report frequencies at 1/10 of a hertz, 100 millihertz too high. They're consistently too high, and we don't understand why at the moment. So I have the equipment to do that calibration here, to do some comparison between different transmitters. We've been using GPS stabilized QDX, driven by a WSJTX. As we've discussed before, that system for transmitting involves uncertain stability and accuracy of the audio sound card. And I think someone, maybe it was Gwen, G3CIL, did a test where he found some sound cards were off, frequency off, at 1500 hertz, were off by 100 parts per million or more. So that's a significant error in transmission accuracy. So whisper sound, in contrast, I have great confidence in that the whisper sound is actually transmitting exactly within microhertz of accurate frequencies. So my test here for the transmit receive system frequency accuracy, it involves having a QDX GPS stabilized QDX transmitter, a whisper sound transmitter, GPS stabilized, and two receivers, also GPS stabilized. Everything stabilized by Bogner's. And the frequencies and the spreading values should come out. They should all be the same. But right now, we have in tests that Glenn has done, we're seeing frequency differences. We're
Rob?
also, yeah.
A couple of things. One, Bodnars are known to be a little bit off at certain frequencies. So that may be what you're seeing there.
I mean, this is
And
this
a
would
common crystal can be off by 100 parts per million. So
Well,
that may be what a common sound card may be only
yes.
that accurate.
Yes, I think that I think the use of a sound card in the kind of transmissions we're doing may be problematic. So the WSJTX transmitters, of which there are many out there right now, right? Most of them are transmitting using JTX.
Yeah, the person to talk to about the Bodnar and its accuracy is John Ackerman.
Yeah. Well, as I understand it,
he's tested that quite accurately.
Yes, yeah, and I think he established that there was he was off by several parts per 10 to the minus 12. 100 millihertz, it is, it's 10 to the ninth. It's orders of magnitude off from what we have, and it's very. So I think that's. Thank you. I think that I was aware of it. I don't think that's. I don't think it's a Bogner error, introduced error, and I have used other. We do have Glenn's reference board that John Ackerman's building, the GERT, as a second GPS reference that he has rubidium standards he's testing them against.
Right.
So I think
that's being fed into a Silicon Labs chip too as well, right?
It's being fed into what?
The clock on the RX-888 is the Silicon Labs chip.
Yes.
That may be off too.
Well, these are external clocks. The clock calculation. Actually, we don't see the problem on the 888. I believe the 888 is right on.
Okay. Which is where are you seeing the error?
Oh, the Kiwis. Yeah. Which and there's been some change in Kiwi software. They've upgraded the FPGA audio processing to better suppress audio sidebands. That has introduced a bunch of new things to address. I mean, we had studied the Kiwi extremely accurately in depth several years ago, but it takes years to become really familiar with the receiver. And then they go and change the audio for the better, I'm sure, for most things, but it's certainly it's a perturbation, and we're still learning about the 888 in that way. One of the ways I've been learning is looking at 888s and finding that there's a lot of sites are overloading, some quite severely, and these are not from local transmitters. This is a diurnal variation. I mean, I logged on to KFS at 4 a.m. the other morning. It was severely overloaded. And I looked at the spectrum on the Kiwi, since I can't look at it on the 888. I can't see the 0 to 30 megahertz spectrum. I looked at it with the Kiwi. There were lots of 40 meter shortwave broadcasts. None of them was above minus 35 or so, but that was enough to even though the 9Q was reporting DBFS of minus 16, minus 17, it was severe overloading. So there's enough correlation between those apparently instantaneous correlation between these signals, these shortwave carriers, that there are plenty of instantaneous peak values that
I find that very hard to believe. I really do.
Well, I that's the only thing you have another theory. You think somebody's driving by KFS in the middle of the night.
Something else is doing it. Okay. Okay.
Hang on, I'm here.
I mean, a little math here. Okay. I mean, everybody knows what the two-tone test is for testing ham transmitters.
Yeah.
I mean, one tone has a peak to average power ratio of 0 dB, right?
Yeah.
Two tones, you already go to like infinite, right?
Yeah.
And if you have lots and lots of independent tones, it becomes Gaussian, and it becomes an infinite peak to average power ratio. But the practical ratio is like 10 to 15 dB, and that's why I recommend setting the input level to about -10 to -15 dB. Unless you're getting strong momentary signals that are overwhelming the A to D converter, or just one. It might even be distant, but if it's extremely strong, it dominates everything else. I can see that too. I just don't understand how this is happening. I mean,
well, I don't either. I agree
don't
with
understand it, and I want to understand it. You guys are scientists, right? I mean, rather than just wonder why serendipitous discoveries, have changed the world, right? So.
Well, what I did with the Kiwi to try to pursue to try to learn what is causing these overload events. But I think, just as an aside, Tom, I don't know if Tom's video presentation has included a discussion on this subject, but I use your your control program, and now that I understand the fields better, I find it absolutely essential tool in configuring a site, any triple eight site.
One possibility is that the DBFS figures I'm giving you are not averaged over a long enough time, and there are spikes that you're missing.
Maybe. Okay. I mean, I can make some recordings. I can do some wave file recordings because, when this happened,
the whole spectrum.
But that's it. But yeah, but well, no, I can't easily make a whole.
I need the whole spectrum.
I know. I realized that just after I said it. You need the whole spectrum, and I actually have. There is a way to do that. I actually did. Franco wrote for me a little split program, and there's a RX888 cat or something. I forget what it's called, but I wrote a little script that pipes the output of this the full spectrum output, pipes it to the split program, and it can write it out to uncompressed onto a local hard disk. So I could actually make a recording while this is happening, but it's a whole day's work to set it up. So
I am doing those. I'm doing those deep. If you look, I'm doing those DBFS calculations over relatively short periods of time. It's a lot of data because the sample rate's so fast. But I think doing over single USB buffers as they come in, which, if I recall correctly, is about 1/4 of a meg.
Yeah.
Franco, I think, set that. I played around with it, but I haven't changed it that much. Now, a 1/4 of a megabyte is long enough to get very good statistical smoothing, which is why the number doesn't change much. But it's still a relatively short period of time, so that you could still be missing very short, strong impulses, and they're there. You just don't see them.
You do that. So you do that periodically, not continuously.
No, I do it continuously, but it's being sampled by control, right? Control by default is only sampling every 1/4 of a second or so, and but the internal value is being updated every time one of these USB buffers.
I see. Okay.
So you're undersampling. You could easily be missing, because I'm not smoothing. What I could be doing is smoothing over a longer period of time. In fact, I should do that. It's an exponential smoother. It's extremely easy to do. I should probably exponentially smooth over a second or so. Of course, if I smooth over too much time, then the spikes will be averaged out, and I'm missing that way also.
Yeah. Well, I don't. Go ahead.
You're getting spikes from somewhere, and I doubt seriously that they're from multiple sources. I mean, if they're multiple sources, they're very unlikely to give you that kind of behavior unless they're very close to you. So something is
Yeah, I was
happening.
thinking.
Yeah.
Yeah, the other thing you could do, Rob, is remember for Clint, I create a program that saves an Instagram. So you could have an Instagram and see if when you have a spike is white Gaussian noise or whatever distribution you see. So they would tell us, what kind of stuff you're looking at. Make sense?
I mean, it could be something as simple as lightning hits that are being
Yeah.
propagated to you that are very, very strong, and you happen to be missing them.
Well, I don't know. It is a characteristic I've seen at several sites that 4 a.m. to 6 a.m. At many sites seems to be the time when there's the most overload events.
Oh, you pointed out that that's on the gray line, and
Yeah. So
maybe
yeah.
the HF gurus here can tell us, how what happens on the gray line when the gray line happens to include, let's say, lightning storms along that path. I mean, do you really expect to see a very large increase in received signal power from lightning storms? Because you said it was always happening on the gray line, right?
I believe so. That's what I remember from looking at the Kiwi logs, the Kiwi overload logs. I wanted to add, as soon as I get this scrape done, I want to add logging of these overload counts, new overload counts. I would add that information to the spots the way I do with Kiwi reported spots. I get an overload count value from the Kiwi, and I believe I can get a version of control. There's a -N option to control that just does one line at a time. Is that
Yeah. So
the
you can grep things more easily.
yes, I can grab things out. So N and I think you had a C for a number of things to output. So if I did as I recall, it was -N-C1 would.
That's right.
If I run that, I'll do one sample, and I will compare the current count against the one I got two minutes.
Okay. Just remember that when you sample statistics inside of Radio D using control, if you're sampling them per channel, there are integrators kept per channel, and they get reset every time you sample. So you could average when you look at a channel, you're averaging over whatever your sampling rate is. So you can average it over a very long period of time if you want. I do not do that on global statistics, like what's coming in the front end. I do not do that. Okay. So you are sampling something that's changing. It could be changing very rapidly.
The only thing I really would look at would be the overload count, which is the global.
I understand. I understand that. Okay. What I'm saying here is that I would very much like to know why that is, because I think there might be something scientifically interesting in figuring out why that is happening.
Well, the other thing is you do have your spectrogram, right? You have the data that could be, and that would, if there were a way to extract from that stream, say give me the 50, strongest frequency bins, that would be a relatively small amount of data, and that might give us some insight into which frequencies. Although I'm not sure, what do you learn if there's you would learn something, but obviously when there's overload events, there's noise spread across the whole band. So
I mean, there's two issues here. One is the practical engineering problem you're trying to solve, and the other one is scientific. Why is this happening? Right? I mean, I like why. I think there might be something to learn here. I mean, I think if you're going to do that, what you really need is the ability to just trigger a recording whenever this happens. Start triggering.
Well, all you have to do is add a full band record feature to Radio D. I know that Radio D, using Franco's code, I know that I can write a full spectrum, and it's amazing. It was amazing to me that you could Radio D. Well, no, it wasn't Radio D. It was this AAA CAT program. It spits out 125 megabytes or so of data at 64 megasamples. You can I can write that to RAM disk and run FLAC to compress it, and FLAC can compress it down to less than to like 80 megabytes a second.
Right.
On a different CPU core. So it runs in parallel. and at 80 megabytes, you can write continuously to a rotating hard disk.
Right.
So I can write hours of
Yeah,
full
we've
spectrum
always
data.
known that it's easy to record short bursts, which is what we're really interested in here.
Well, this is
The
the
challenge
I
is
could
recording
no,
continuously.
you can run continuously. I ran and
Okay,
ran
great. Well,
continuous recording, but we need
do
your
it.
interface. No, I can't do it because you don't provide that interface. See what happens if I do that. I have to
Got the
stop
source
all.
code.
I have to stop. I have to stop all recording. Okay,
Yeah.
stop radio D, and then I can run Franco's code on the same ARC 888. So that's
Okay.
it's a
All
simple
right. Well, okay.
software
How about some
development task.
kind of triggered scope feature where if you get more than so many A to D overloads per period of time, it triggers a recording of so many milliseconds of A to D data.
You can tell the trigger to I'll give you a file. I'll give you a file name. Okay. You can write to 2.5 gigabyte per second to these RAM disks.
All right. Well,
okay.
look, I mean, all I really need, if you're telling me that these are intermittent events, there's no need to record continuously. It's just more data for you to throw away later, right?
Yeah. Yes, it would be, but it would be good if you could trigger.
Okay. Because
and
you know the reason I've been resisting putting some kind of front-end AGC in here is because all I can do, I mean, the only possible thing I could do with this AGC is to reduce the gain, right?
Yes.
It's the only possible outcome is I can reduce the gain. I can't work magic. All I can do is reduce the gain, which is going to hurt your noise figure elsewhere. So if you could understand why these things are happening and what the cause is, okay, and better understand, we can figure out, first of all, if this is something we just let happen because you're not really going to improve the overall performance of what you're trying to do by reducing the gain, right? Or maybe we can find out there's some other reason. I mean, it drives the engineering decision here. I don't want to just do something blindly, without understanding why I'm doing it. That's all. That's why I've been resisting.
No. You make a reasonable point. Well, it just as
look, I'm an engineer, not a scientist. I keep saying this all the time, but here I'm, playing the scientist. So
no, you're right. I mean, it seems like that this is important though. We need to validate the received data that we're getting, and we're not. I don't know how grape.
And we need to understand whether it's something, an artifact in my system, or whether it's a real thing that comes down the antenna line.
Yeah.
If that's the case, then we would like to understand it, wouldn't we? I mean,
What kind of filtering?
Propagation group, right?
Yeah. What kind of filtering do you have on the front end?
You have the AAA has no filtering on the front end, but all of the sites that AAA sites, Whisper Daemon sites, have a lot of filtering. Most all of them have the shelving filter that Phil Paul
you mean
Elliott.
analog? You mean analog? Okay.
Yeah, the analog in the front end, and usually that's enough. The shelving filter is one that cuts off.
Yeah, but you could have all manner of things out of the band of interest that are coming in and overloading the DAC, the ADC.
That's yes, and
you wouldn't know it.
No, we would see it.
Yes, what we're seeking to know it to see how much we could know it.
But you'd have to be looking at the entire spectrum rather than.
That's just what we've been discussing.
Sure.
That's exactly what we've been. That's just what we've been discussing doing. So
I mean, the problem here could be something as simple as a loose SMA connector that occasionally wiggles and introduces. Who knows? We got to figure this out first.
Yeah,
true enough.
Yeah. But now most of these sites, the most Whisper Daemon sites, have extensive and customized filtering ahead of the receivers. They typically, the 888, like the Kiwi, needs a low noise amplifier up in front of it at 10 meters and 15 meters and so on, and of course it needs to be cut down at the lower frequencies where where you get your AM broadcast and shortwave broadcast.
Okay. Let's rule out the simple stuff first.
Yeah. So anyway, if you
go over and tighten all the SMA connectors first.
This happens at too many sites. By the way, over at Glenn's site at Glenn N6GN, he's transmitting Whisper 5-watt Whisper transmitter on a dipole that is about 3 meters from his receive antenna.
Sorry, I
And
can't fix that.
it actually, listen to what I did. I went and I said, okay, what does it take? I turned down the RF gain from the normal plus 20 on the 888. I configured it to -5. So you're down 25 dB. His spot, so now he gets 0 overloads, even when he's transmitting. Okay. And he's still getting a 90% of the spots that he was getting before.
Oh, okay. A to D has
So
a better
you're
range than we thought. Okay.
Yeah. So the dynamic range of the system is extraordinarily high, and so which attribute to the 16-bit A to D and to and to your software, Phil. It does a great job. So it's a, but so it is possible to do that. But the ideal solution at Gunsight would be, of course, to detect that he's starting to transmit and turn down the gain only for the 2 minutes that he's transmitting.
That's an important special case that I agree is worth handling, is a local transmitter. No question about it.
But
I mean,
but
I have
even
that problem.
even without it, the only problem you have is that, of course, if I log into it, I have no way. If he's not transmitting, I have no way of knowing that. So without the logging feature, which is my job, is to put in the overload logging. Once I have that, then I can look back at the log file and look over a whole day and see when overloads were occurring and how severe they were, and that's the first clue. So that's an
A local
area.
transmitter is a very important special case. I have this problem myself. Among other things, it was screwing up my N0 averages because I average over a very long period of time. And a local transmitter completely screw up my noise averaging algorithm. So I made some partial fixes to that.
Well, okay. Well, anyway, that's I owe you some code, overload monitoring code.
I'm going to be traveling through the ham venture or the hamcation. So
yeah,
I don't want to actually.
No rush. There's plenty of work for me to do.
All right, we've beaten this one to death. So before everybody else goes off to sleep, I wanted to ask Nathaniel, he's still listening, is still awake.
Thank you for.
Okay.
Yes, I'm still here, but I am
in
fading.
general, okay, besides its utility for honest research, I mean, can we just list the properties of ham radio that make it potentially useful for scientific research? And the things I can think of are, there are a lot of us, and we're in lots of places. And most importantly, we now have a lot of enabling technology. We have GPS. We have extremely powerful computers. I mean, it's hard to believe. I've done the numbers several times, but a Raspberry Pi 1 is several times the speed of a Cray 1. I mean, I've done this several times, and I still can't wrap my brain around this fact, but it is true. We have the cheap hardware. All we need is the cleverness to use it.
Yeah.
And I believe that there are many clever people in ham radio. And, ham sci is just one example, but I think in general, the general properties of ham radio that make it potentially useful is that there are a lot of us. We have some very powerful tools that we didn't have not that long ago. And we also have some people who are very enthusiastic. They're not doing this for money. They're doing it because it's fun. And that actually describes most scientists that I know, even if they do it for a job. I mean, that's not why they're doing it. They're doing it because it's fun.
Yeah.
And I mean, those are, I mean, can you think of anything other inherent properties of ham radio that make it relevant here?
We have access to many different frequencies, many different bands.
Okay.
So
we have a sample of the spectrum all across. Yes.
A sample of the spectrum all across.
That's a good one.
Yeah, and different modes, of course, too.
I think we can do anything we want. That's
right.
What we have the freedom to do whatever signals we want within fairly broad parameters.
Yeah.
That other services don't have.
Not only are there a lot of clever people out there in ham radio, we have a certain community and camaraderie that allows the clever people to talk to each other and share ideas in ways that make the clever people more clever because they're working with other clever people.
One of the other things that's unique to amateur radio is we can build things and put them on the air. without
Yeah.
a whole lot of interference from government sources.
Regulatory simplicity, I guess.
Right.
The other thing I'm thinking is the combination of the ham sci stuff is you get into ham radio and then you get into the ham side, so you have to learn the physics of the science if you're doing magnetic or if you're doing ionospheric propagation. It pulls you into learning more different topics through ham radio. And AMSAT is the same way. You learn about satellites and orbiting and propagation and all that. So
That's certainly,
microwave
I mean, that
radio is the same way. It's high frequency and it's data communications at very high rates, learning to use those frequencies. And unfortunately, they're taking our microwave frequencies away from us in some cases. And so it should be emphasized that hams need to be able to experiment at those frequencies because they end up introducing ideas that aren't found otherwise.
Right. Okay. Yeah, that's important. I mean, what you were just saying, Bob, was, I mean, that's directly relevant. I mean, to ham radio's role in education. The point I'm trying to work on here is ham radio's ability to serve scientific research through projects like HamSci. I mean, what are the underlying generic features of ham radio that make it useful for a project like HamSci or scientific? I mean, it's HamSci is real academic research.
And another thing that's kind of interesting is many scientists typically look at data. You look at plots, but they don't necessarily listen to it or experience it the same way amateurs do. So amateurs have used some of their other senses and intuition, and that can be useful.
Okay, more intuitive, in a more intuitive way of approaching problems.
Yeah.
You remember the beginning of the movie Contact with Jodie Foster actually listening on headphones?
Mm-hmm.
I mean, that's kind of silly, but it is kind of the spirit of what hams might do.
Yeah, absolutely.
Yeah, I mean, in real SETI doesn't work that way, of course, but
no.
But it does. I always thought that was a fun scene because it did just kind of show in a kind of a very direct way, how hands-on some people are. And actually, there's not, in that way, there's not that much difference between scientists and hams. I mean, we both do things because we love to do it. And we both have this camaraderie. I mean, scientists love to talk to each other.
Yeah.
So do a ham. I mean, there is some competition, of course, there's sometimes a rush to publish a new discovery. A lot of hams probably wouldn't even bother with that. They would probably just do it. So anyway, I've made a list of notes here. So thank you. If anybody think of anything else.
Did you get the link to the paper I put in the
I
chat?
did. Yes, I
okay.
did.
That's
why I said I've yet to see a scientific paper less than 10 authors.
Yeah. I put 2 other papers in there that are from Ted Rappaport.
Oh yeah, I've been talking to him.
Yeah, so he's writing a 3-part series, and the first 2 parts have been published in IEEE. And so the first two parts are there in the links.
Good, thank you. Yeah, I was actually a source for this. I don't know if if he mentioned me or not, but I was a source for the first 2. And I just talked to him within the month on his part 3. And thank you. It just reminded me that I owe him a whole bunch of back issues of AMSAT Journal and Tapper newsletters and so forth that I've been meaning to put online. So thank you for reminding me, or prompting my memory on that.
Sure.
So yeah, I'm going to mention these papers. I mean, these are really well done. And I'm going to
Speaking of radio and science, Phil, I would also like to remember now. I don't know if you saw that Arno Penzi has died a few days ago.
I did. I did. Yeah.
And I was at Bell Labs, so I kind of saw him. And it's interesting the story how they found actually the background radiation because they thought there was noise from the horn antenna they had in Holmdel.
Right, right. They weren't even scientists. They weren't even looking for it. You know, they were just ruling out causes. I think they were looking at bird droppings on the dish.
Yeah, that's what I read. They were bird.
Yeah, yeah. I didn't know him personally. I mean, I moved out of Bell Labs after a couple of years, so I never met him personally. But there's some great stories about him. You heard how they pranked him at one day when Penn Jillette, the magician, came in to visit. You hear about that one?
No, I don't know that one.
It's a good story. You can find it on the web, but they were able to prank him into thinking that they had created an artificial intelligence program that could emulate Pendulette, and it's pretty funty. So yeah, you can prank even a Nobel laureate, if you really want to believe something.
Let me mention something that I wanted to talk that kind of dovetails into what Rob is talking about and working on.
Yeah.
And that I've been collecting data now for 6 months, roughly, on magnetometer data, and then I've got several months worth of RF data for WWV. And I know that a lot of other people have done so as well, and it's being uploaded into the server. But there's like no way to score that data or for any feedback about the quality of the data. And in some cases, maybe 25% of the stations, the data is not useful because it's not of the quality that's needed. And part of it is related to Rob's discussion here about how these devices are varying and whether or not they're on frequency or off frequency. And there is really no simple system to determine at the endpoint, at the server point, where your accuracies were or where they were not. Because you need to be scoring, I think, each data collector in some way. So there needs to be a systematic way that, we either all look at a particular event that happens or a particular transmission of a radio signal or a particular magnetic field disturbance and compare one station to the next to decide who's contributing good data and who's not. And it's worthwhile.
Yeah.
A lot of energy is going into collecting this data and passing it along, but not so much about verifying its usefulness.
Yeah. I think we're working towards that. So, we Hyomin just submitted a paper about the whole about the magnetometer to the hardware external. Unfortunately, and so some effort went into, discussing how it's made and a little bit of validation in there as well. Not the level of validation that you're looking for, but starting to talk about some of those ideas. I have to say we've hit a little bit of a snag with that paper at the moment. And the issue is they're claiming that because we already wrote a lot of the text on the HamSci website, they're saying that they don't want to publish it because it's already been on the HamSci website. And we're saying, well, no, the HamSci website's not peer reviewed. I mean, that was our process for developing the open source documentation. And they haven't come back with an answer, yes or no, yet about that and how to handle it. So they've been very slow to respond and have not been helpful. But to address, and so once we do get that paper out the door, I think the next step for Hyomin or someone on that team would be to, like you said, do some sort of a study where we actually take the data and try to, do a scientific study with it and show how it's useful. So that's one way of doing the validation. Another way that I would like to see happen, and I think this is going to be another grant proposal or something. One route we can go is there's another website called Supermag, which I think many of you know. But Supermag is in the business of ingesting magnetometer data from all sorts of different networks. And they already have a number of algorithms in place on their website for automatically doing like data checking um and automatic calibration. There are certain things you can kind of work out and making sure that data is ready for scientific use. So I could see, writing a grant where we include in there moving our magnetometer data up to the SuperMag website. And I have talked to the SuperMag PI, and he's interested in having that data there. So that would be another possibility. And of course, there's also the possibility of us coming up with our own, in-house routines of, like you said, scoring and, giving feedback. But I think at the moment we've been really a lot of our focus So on our server and collection, you know, Bill has been leading that effort. A lot of the focus right now has really just been getting the grapes up and running for the Eclipse. And so and we've seen a lot of good progress with that, with the Grape 1 digital RFs getting up there. There's now with Bill supporting the Whisper Demon grape data, and then hopefully soon the Grape 2 data, which is coming along. So I think we need to get that stable and then come back to the whole uh magnetometer data checking issues.
Yeah, I'm in a position where I feel like that I'm collecting data and I'm submitting it, but I have a lot of noise in my environment, and maybe I don't have my antenna matched well for the
Yeah.
frequency that I'm listening to. But I'm trying, I'm also thinking, from things that I've heard that, hey, your signal doesn't have to be very strong for us to get the data we're
Yeah.
looking for out of the signal.
Yeah.
And
You
so,
can
I don't want to put energy into something that's
Right.
not needed necessarily, because I have got so many balls in the air that I'm trying to juggle here
Right.
myself. So,
Right. You might email Hyomin and ask him, give him some feedback there too.
okay.
I might call it a night and say 73. But thank you very much, everyone.
Thank you.
You're welcome. Good luck with your talk, Phil.
Thanks.
You're welcome.
And I enjoyed Tom McDermott's video very much. I did see that too.
Yeah, Tom, thank you very much for putting this together.
Yeah, I'm going to bed too. Good night, everyone.
Yeah.
Good night.
Me too.
Good night. 73.